Our topic today is density. You are welcome to today's class. So looking at density, what do we mean by density? If we have three different cylinders and these three cylinders are filled with equal volume of liquids, let us say kerosene, water and honey as shown in the diagram. These three different liquids will vary in their masses when placed on a scale. Oil will weigh less than water and water will weigh less than kerosene. Therefore, equal volume of different liquids vary considerably in their masses. To verify this fact, if the three liquids are all poured in another vessel, as shown, oil will remain at the top, followed by water, and honey, the heaviest, will be at the bottom. Solid also varies in weight, let's say cork, wood, and metal. These three solids, if they are placed in a vessel, you will find out that the cork will float, followed by the wood, and the metal will sink. Gases also varies in weight. A hydrogen-filled balloon rises in air for precisely the same reason that a cork rises in water. Aircraft are made chiefly from aluminium alloys, which are as strong as steel but weigh less as half as steel. The word density is used to describe the lightness or heaviness of different materials in physics. The density of a substance is defined as its mass per unit volume. The symbol used for density is the Greek letter ρ. Thus, density is equal to mass divided by its volume. Now, let's look at the measurement of density. We can measure the density of a liquid by calculation in the lab. What do? The liquid, we will get either a burette or a measuring cylinder to measure the volume of the liquid. After measuring the volume of the liquid, we get a weighing balance to measure the mass of the liquid in a container, which we will now subtract the mass of the empty container from the liquid. By arithmetic, we will now find the density of the liquid by saying density is equal to the mass we got divided by the volume gotten. To find the density of a regular shaped solid, you will weigh the solid and calculate the volume, then apply the formula. For an irregular shaped solid, let's assume a stone. The mass can be determined by using a weighing balance, but how can we determine the volume? Archimedes explained this. Let's digress a little. Archimedes was one of the most intelligent men of his time. There was a king who thought the goldsmith might have cheated him, so he asked Archimedes to help him determine the volume of the gold crown made for him by the goldsmith. He gave the goldsmith a particular volume of gold to make a crown for him, and in those days, kings were lords. Archimedes collected the crown and pondered for many days on how to determine the volume of the crown. And one day, he was about to have his bath. The bathtub was filled with water. As he sank his body into the bathtub, water spilled out, and he realized that the water that poured out is equal to the volume of his body under the water in the bathtub. Books had it that on realizing this, he ran out naked, screaming, "Eureka! Eureka!" meaning I have found it in Greek language. With this experience, Archimedes was able to explain how to determine the volume of an irregular shaped solid by immersing it in a cylinder containing a liquid. The liquid displaced is equal to the volume of solid, or using an eureka filled with water, the excess that is collected in a cylinder determine its volume. Applying the formula, then the density of the solid can then be calculated. Importance of density measurement. Architects and engineers requires the density of different materials in the design of bridges, flyovers, and other structures. Chemists often use the density of a known substance to determine the purity of the substance. This led to the discovery that nitrogen obtained from air was slightly denser than that obtained from other sources. With a series of experiments, they succeeded in isolating a new gas from air nitrogen known as argon. We are going to be taking one example. Find the mass of 40 liters of petrol of density 720 kilogram per meter cube if 1 meter cube is equal to 40 liters. First of all, we are going to convert our 40 liters to meter cube by dividing by 1000, since 1 meter cube is equal to 1000 liters. And we are given the density as 720 kilogram per meter cube. Using the formula, density is equal to mass divided by volume. We will make mass the subject of the formula, which will now give us mass is equal to density multiplied by volume. By substituting and applying correct arithmetic, our answer will be 28.8 kilogram. Now, water at 4 degrees Celsius happens to have a density of about 1 gram per centimeter cube or 1000 kilogram per meter cube. In that case, to convert from gram per centimeter cube to kilogram per meter cube, we will simply multiply by 1000.